three different ways. Okay, now when we get to letter D, we're going to solve by the equal values method. Okay, so it's important that we get B right, because if you don't get the equations correct, if you don't get this equation done correctly, then we'll have some trouble down here trying to figure out the equal values method. Okay, so in order to do this, I need to have both equations in this form, the y equals mx plus b, and then I'm going to make them equal to each other. Okay, so I'll take that first one, 2x minus 2. Okay, then I'll take the second one, negative 1 half x plus a. Okay, and now we can solve it. Now, some of you guys are looking like, oh wait, what do we do with the fraction? What do I do with that? Okay, well, to cancel out a fraction, to make it easier to deal with, we multiply everything times whatever's on the bottom of the fraction, the denominator. So I'm going to multiply this side times 2, and also this side times 2. Okay, so what happens when you multiply 2 times the denominator? It's going to cancel. Okay, so now on the right side, this cancels, and I just have negative 1 and x. Okay, but then I also have to distribute the 2 to the 8 as well, don't forget that. So that'll be 16. And then on the left side, 2 times 2, x, 4x, 2 times negative 2, negative 4. And now it's a little easier to solve. Okay, that's how you get rid of the fraction. Just multiply times whatever is in the denominator. Okay, and then it cancels out. And remember, you're only left with just the whatever number's on top. Okay, you don't bring this 2 back down here. Okay, so now solve it just like we've done before. I want the x on the left, and I want numbers on the right. So that means this 4 does not belong. Add 4 here, and I'm going to add it to the 16 on this side. Okay, that cancels. 4x equals negative 1x. 16 plus 4 is 20. Okay, and now I go to this side. Remember, if I cancel here, I have to go to the other side to cancel now. Don't go to the same side to cancel. Don't do minus 4x. I see a lot of you guys doing that. I canceled a number here, so I need to cancel an x over here. So I'm going to cancel the x. It's negative, so I'm going to add it to both sides. Okay. And I'm going to continue my work up here because I'm running out of space. Okay, so now 4x plus 1x, 5x. That cancels, and then we just have 20. And then just like the first step in the first problem, or the last step in the first problem, we divide. That cancels, x equals 4. But again, don't just find x, also find y. Okay, so now we're going to take that, plug it into the first equation. So y equals 2 times 4 minus 2 times 8 minus 2 is 6. And again, we get the same answer, 4 and 6. Okay, so make sure when you go through those 3 problems, you should get the same answer. Let's say you go through all 3 of them, and then 2 of them have the same answer. There's a good chance that that one that has a different answer is probably the one you messed up on. Okay, number 2. Now, in this problem, we're given a system of equations, and some of us right away are going to think, oh, go ahead and solve it. And you could solve it. That's one way to do it, is just solve this equation. Do elimination, eliminate, and solve it. But let's read what it's asking to do. Glenn thinks that the solution to the system is negative 5, 0. So this guy thinks that the answer is negative 5 and 0. Is he correct, excuse me, or incorrect? And be able to justify that. So basically all we're doing is checking to see if that's correct or not. Okay, in order for a point or your answer to work for these 2 equations, they need to be able to make both of these equations true. And I'll show you how to do that. Now again, I can just solve this. I can multiply, change the equations, multiply this times 1, this times 3, change the equations to negative 3x plus 2y That one doesn't really change. And then also multiply here. Okay, and then that's 21. Cancel that and go ahead and keep solving it. And then find the answer and see if it actually matches that. But there's a way that's much easier. You take this point and you simply just plug it into both equations. So I'll take the first one, negative 3x plus 2y equals 15. And wherever there's x, I'm going to put negative 5. So negative 5 goes here. And then 0 goes here for y. Okay? So now I multiply it through. This is going to be positive 15 because it's negative times negative. Not negative. 2 times 0 is just 0, so that's going to cancel out. I don't need that anymore. And then I say, does 15 equal 15? Yeah. So then I know it works for that one. But here's the thing. Don't just check one, you got to check both. Because it may work for one of them, but it has to work for both equations in order to be the solution. So now I'm going to check the other one, x plus y equals 7. Okay, so now I'm just going to plug in negative 5 plus 0 equals 7. Okay, negative 5 plus 0, still negative 5, and then 7. And if you notice, that's not equal, obviously, right? That doesn't work. So this is not a solution to the system. It worked for one equation, but it did not work for the other. Okay, so then you would say, no, this is not blah, 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 a solution, okay?